Now we're going to start looking at factoring, and we're going to start with monomials and something called GCF factoring. So to begin with, let's review what it means to factor. Okay, so when I'm trying to make a prime factorization or find the factors of something, I'm looking for what multiplies to get to my answer or my product. All right, so for a prime factorization, we need to make our factor tree. So we look for everything that goes into 98 until we get down to our prime numbers, which are numbers that can only be divided by themselves in 1. So to start with, I know it's even, so 2 goes into it, and that would be 2 times 49, and then 49 is 7 times 7. 2, 7, and 7 are all prime. So 98 is equal to 2 times 7 times 7. That's a prime factorization of 98. So if I wanted to factor these completely, right, to get all the way down to our prime factors. For 34, I'm going to make that same factor tree, and that's 2 and 17, both of which are prime. And then if I have a to the 5th, that's 5 a's. So then this equals 2 times 17 times 5 a's and 1 b. All right, multiply all those back out, and we get to 34a to the 5th b. So if I do it again with negative 52 m cubed n squared, I'll start by making that a negative 1 and positive 52. Then we have 2 and 26, 2 and 13. So this one simplifies to negative 1 times 2 times 2 times 13. And then I have 3 m's and 2 n's. All right, so that's as far as I can break down negative 52 m cubed n squared. So I've factored it as far as it can go. Finding the GCF. The GCF is the greatest common factor. So it's the biggest number that goes into both of these numbers. One way of doing this is by making your factor trees for each. So if I do one for 20, I have 2 and 10, 2 and 5. So that means 20 is 2 times 2 times 5. 42, we've got 2 and 21, and then 3 and 7. So 42 becomes 2 times 3 times 7. Then you look for what they have in common. The only thing they have in common is 1, 2. So that means that my GCF is just 2. 2 is the biggest number that goes into both 20 and 42. So if I want to find the GCF of 12a squared b squared c and 18ab cubed, I'm going to do the same thing. I've got 2 and 6, 2 and 3. So then 12a squared b squared c becomes 2 times 2 times 3, 2 a's, 2 b's, and a c. 18 is 2 and 9, 9 is 3 and 3. So I have 2 times 3 times 3, 1a, and 3 b's. They both have a 2 and a 3 for the numbers. They both have 1a and 2 b's. And that's it. They have nothing else in common. So then my GCF becomes 2 times 3, 1a, and 2 b's. And then if I multiply that out, I end up with 6ab squared. Okay, so that's kind of the long way of finding your GCF. Sometimes you can do it just by looking at your numbers, right? So if I think about 30 and 50, okay, start with a smaller number just to see if that does go into it. But 30 does not go into 50, so I'm going to start getting smaller. I know that 10 goes into both of them. Okay, 15 goes into 30, but 15 does not go into 50. All right, so 10 is looking like the biggest number that goes into both. Right, so I'm going to have a 10. Okay, and then if you notice, up here we had a squared and a. So that means they both had the 1a in common. Then it was b squared and b cubed, so they had the 2 b's in common. And then c and no c, so they didn't have any c's in common. It's always going to be the variable with the smallest exponent. Okay, because that's going to be the one that goes into both sides. So if we look here, I've got q cubed, so there's a 3, and q squared, so that's the smaller one. R squared and r, so r is a smaller one. And then I've got t and t, both the same. So that's the smallest one. So my GCF for the second one is 10q squared RT. The more you do this, the quicker you'll be able to visualize or realize what the GCF is. If you need to, you can always make your factor trees. So now I'm going to do the same thing, but I've got three numbers. So I'm just going to rewrite them so they're all in one line. So I've got 16m squared n, 32m n to the fourth, and 40m n cubed. All right, start with the smallest one. 16 goes into 32, but it does not go into 40. So it's got to be something smaller than 16. If I think about my factors of 16, all right, the next biggest one aside from 16 is 8. 8 goes into 32, 8 goes into 40. So 8 is going to be part of my GCF. And then I'm going to look at the smallest exponents. So I've got an m squared, an m, and an m. So m to the first power is the smallest. I've got n to the first, n to the fourth, n cubed. So n to the first is the smallest. So my GCF is 8mn. Now we're going to factor by taking out that GCF. Okay, so we got to find our GCF for all the terms, and then we're going to pull it out. So before, we've multiplied using the distributive property. Okay, anytime you have a monomial times a binomial or trinomial, you just multiply. So like this 4 out front, I would distribute to the w and the 9 and get 4w plus 36. So factored form is when it's being multiplied, and then once you multiply it, that gets it to standard form. So now we're going to go backwards. We're going to go from it being multiplied out to taking out that GCF, and this is what we call factored form. So to do that, we find our GCF. So if I look at 27y and 18, okay, 18 does not go into 27, so that's not my GCF. So some of the factors of 18, the next biggest one is 9. 9 goes into 18, and 9 goes into 27. So my GCF definitely has a 9 in it. And because 18 doesn't have a y, there can't be a y in my GCF. So my GCF is just going to be 9. So the next step is to put that GCF on the outside of parentheses. I'm taking this 9 out, so I'm going to divide. When that 9 was on the outside, to get it on the inside, you multiply and you distribute it through. Now I'm going to divide to take it out. So 27y divided by 9 becomes 3y. And 18 divided by 9 becomes 2. If you take out the correct GCF, there should be nothing left in common with the numbers on the inside. And 3y and 2, they don't have anything in common. They do not have a GCF other than 1. So that means that this is correct. You can always check your work by multiplying and distributing it back out. 9 times 3y gives us 27y, and 9 times 2 gives us 18, which is where we started. So I want to factor these. So for the first one, 5m and 15v. All right, start with the smallest one. 5 goes into 15, so 5 is going to be part of my GCF. This one has an m, this one has a v, so there's nothing in common. So 5 is the only thing I take out. Then I divide. 5m divided by 5 is just m, and negative 15v divided by 5 is negative 3v. For b, I got 3x squared and 27x. Start with 3. 3 does go into 27, so that's going to be part of my GCF. And they both have x's. I have an x squared and an x to the first power, so the smaller exponent is in my GCF. Then we divide. 3x squared divided by 3x. The 3's cancel. I go from 2x's to 1x. And then 27x divided by 3x. The x's cancel, and 27 divided by 3 is 9. And then for the last one, 36 and 24. 24 does not go into 36, so we'll start working our way down. The next highest factor of 24 is 12, and 12 does go into 36, so that's part of my GCF. I have an a cubed and an a, so a is a smaller exponent, and then both of these have a b, so b is in my GCF. 36 divided by 12 is 3. A cubed divided by a is a squared, and then b divided by b cancels. Negative 24 divided by 12 is negative 2. A divided by a cancels, b divided by b cancels, so I'm left with 3a squared minus 2. Okay, same thing, but now I've got a trinomial. Nothing else changes. I still have to find my GCF. Keep in mind that in front of this ut is a 1. So I've got 7, 21, and 1. 1's obviously the smallest number. None of these can go into 1. So I don't really have a number that's a GCF other than 1. So 1's going to be part of it. So I can put a placeholder there for now. Then I have u squared, u, and u. So the u's are my smallest exponent. And then t squared, and t. T is my smallest exponent. All right, so 1ut is the GCF. You don't need that 1. You can put it if you want to, but it's not necessary. So then I'm going to leave a bigger parentheses this time. 7 divided by 1 is still 7. U squared divided by u is u. T squared divided by t is t. 21 divided by 21, still 21. U divided by u cancels. T squared divided by t is t. 1 divided by 1 is 1. U divided by u is cancels. T divided by t cancels. And so I'm left with just 1. You always had to have as many terms in your parentheses as you started with before you took out a GCF. So I have 3 terms here. I'm going to have 3 terms in my parentheses. Okay, you can always check because the 3 of these should not have anything in common. All right, so yes, the first one has a U, but the last 2 don't. And then these 2 have a T, but the last one doesn't. So there's nothing that all 3 terms have in common, which means we took out the correct GCF. Remember, you can always double check. UT times 7UT becomes 7U squared T squared, and then 21UT squared, and then negative UT, which is where we started. Okay, next we're going to talk about the zero product property. Okay, so whenever we factor, this is going to be one way that we solve quadratics. So we're going to have to get down to x equals something, right? And one thing we use is a zero product property. If I have 2 terms that have to multiply to 0, okay, so for example, if we say x times y equals 0, the only way to multiply to get 0 is if one of these terms is 0. Like 5 times 0 is 0. 0 times 0 is 0. So we have 2 options. Either the x can be 0, or the y can be 0, or both. So the way that we solve is if these 2 terms have to multiply to get 0, we're going to set both of them equal to 0. So I have one option if x minus 3 equals 0. And then I could also have x plus 2 equals 0. Okay, both values of x, whenever I solve, if I plug them in, will give me a product of 0. So if x minus 3 equals 0, I'm going to add 3 to both sides, and so we get x equals 3. X plus 2 equals 0, I'm going to subtract 2 from both sides, so x equals negative 2. If I plug in 3, 3 minus 3 is 0, 0 times anything is 0. If I plug in negative 2, negative 2 plus 2 is 0, 0 times anything still gives me 0. So whenever we solve, we're going to factor these equations out and then take each one of our parentheses and set it equal to 0, or each one of our factors. Okay, the ones that are one step are easy, right? Add the 3 over, so m equals 3. Sometimes it's 2 steps. Subtract the 3 first, so 2m equals negative 3. Then divide by 2, so m equals negative 3 halves. For b, 3m needs to equal 0. M plus 9 needs to equal 0. Divide by 3. 0 divided by 3 is still 0. Subtract 9. M needs to be negative 9. And then for the last one, 2w needs to equal 0. W minus 4 equals 0. Divide by 2. W equals 0. Add 4. W equals 4. So just set each of your factors equal to 0. And for our final example, we're going to factor this using GCF, and then we're going to set them all equal to 0 to solve. So if I look at my GCF, 8 goes into 40, so that means it's got to be 8. Both of them have m's. The smaller exponent is m to the first. If I take out 8m, 8 divided by 8 is 1. M squared divided by m is m. Negative 40 divided by 8 is negative 5, and then my m's cancel. So my 2 terms are 8m, set equal to 0, and m minus 5, set equal to 0. Divide by 8, so m equals 0, add 5, m equals 5. So when I solve, I end up getting m equals 0 and m equals 5. If you recall, we have 4 words that mean the same thing. We got 0, root, solution, and x-intercept. So by solving this quadratic by factoring, I was able to find my x-intercepts on my graph.